All right, so our group is Academic AI, and we are presenting on the topic of object detection. All right, so object detection is a part of computer vision. Computer vision is a branch of machine learning focused on interpreting digital images and their features. Object detection is the part of computer vision that is about localized image classification. Localization involves the identification of bounding boxes around objects in an image, which is shown in this picture by the boxes that we see around each object. And then image classification is a machine learning technique used for categorizing images, which is shown by the labeling of the boxes. So there are two distinct methods for object detection, a two-stage approach and a one-stage approach. The two-stage approach is RCNN, which stands for Region-Based Convolutional Neural Network, and the one-stage approach is YOLO, which stands for You Only Look Once. So RCNN is the most popular example of the two-stage approach for object detection. It is the first object detection algorithm that uses a neural network. And neural networks are a key component of AI that enables computers to process data inspired by human brain functioning. This works by using complicated math functions that are essential for image classification by extracting relevant features for recognition.
All right, so the two-stage approach for RCNN, I'm going to explain as steps. So for step one, as you can see in this image on the left, is just an image. For that arrow where it directs to that second image, it is proposing objects in the image. So it's looking at the image and trying to find objects anywhere in the image and trying to see these, which object it could potentially be in this image. So this is called region generation. It's a phase that identifies potential areas, as I said, in this image where objects may be situated. The image undergoes cropping of iteration. So it makes all these little boxes in the image, trying to figure out where the objects are in this image. And then it crops these little iterations of it. And it results in, various cropped images, which is going to be used in the second step. The cropped images are then formatted so that it can meet the specifications of the next stage. And this step is dedicated to pinpointing the areas in an image of potentially where these objects are. So it's just, as you can see in this image, it's approximating right now about 2,000 object proposals just in this one single photo. For the second stage of RCNN, you can see we're at that approximation of 2,000 object proposals, and you can see it vastly, downgrades to a 20 object detection. So how it does this is called feature extraction. The phase involves determining the probabilities of the objects that are in the image and their classifications. So with feature extraction, the process will outline, they're called boundary boxes around the identified objects of what it thinks it is by these high probabilities. And then with the actual object detection step, it classifies the recognized objects based on their features. So it will, let's say on the image on the right, there's 20 object detections, but you can see that there's boundary boxes around, a human or a bicycle. And so it then classifies it at that point. For a broad overview of RCNN and the two-stage approach for this, I just wanted to show you a little chart. And the two-stage approach has two steps. So the first step, which is a combination of inputting the image and extracting the region proposals. So this is where it's doing the approximation of where the potential objects could be by putting a bunch of these boxes on the image and just trying to find everything in this image. Then it goes through the convolutional neural network, where it then has it computes its features, where it then does the object detection step of classifying the regions. So as you can see here, it broke it down to a person, so it's seeing, is it an airplane? No. Is it a person? Yes, it probably has a higher probability that that is a person and classifies it. For YOLO, it's called You Only Look Once, and it's because it has the one step, so hence the once. It combines the region generation and the feature extraction in a single step. So these two steps were in RCNN. It combines them so that it has one step. YOLO is the most popular for the one-stage approach of object detection that's out there right now. And just to break down a bit of the one-stage approach, so how it does the one stage is that it skips the region generation step. So instead of, dissecting the image and trying to potentially see every object that's in this image, it divides it by putting a grid on the image. And it doesn't even care what's in, the cell of the image at this point where it has the grid. On the right, you can kind of see that it has a bunch of lines that kind of look like a grid, and then there's two major boundary boxes that you can see on the right hand side. So instead of like specifying the areas of the objects, it treats the image as a grid. So it looks at multiple cells to determine, within that cluster of cells, is that an object? Is that a high probability of an object? That's why you see in this image on the right, there's two boundary boxes, because you have the first cluster of images, or sorry, of cells, where it detects an object, and then also that second boundary box as well, where it determines that over multiple cells. So we're at the stage where it can see two boundary boxes, right? Where it's detecting that there's two objects, or it could be more. It addresses objects. So how it does the spanning of the multiple cells, it utilizes the intersection divided by union, which is a mathematical equation. And it establishes the classification of the object, with the outcome of this equation. So you have your multiple cells, it sees that there's these two objects, and then you can see that it classifies it on the right-hand side, where you can see there's a dog, a bike, and then even a car. So that's like that third one. You can't see too much on the left, it's barely there, but there is a little boundary box that is on that left image for it. And that's how it determines in that one step. So just to compare the two approaches for object detection, and is that RCNN has a two-stage approach, and then YOLO, You Only Look Once, has the one-stage approach. For RCNN, it offers greater precision because it's dissecting the image and it's breaking it apart into every potential area in the image that could be an object. So the precision is much higher, but it is, it's a bit slower of a process, so it's not going to have as high of a performance. Versus YOLO is much faster because it has the one step, but the accuracy isn't near as RCNN has. So it depends, higher performance or more accuracy is what you want. And that's it for a presentation. So thank you so much.